Hi, everyone. Thanks for joining. I'm Thomas Vitale. I'm the author of Cloud Native Spring in Action, published by Manning. Right now it's available in early access. You can find it on manning.com. This is also a discount code for you, 40% off, not just for my book, but for the entire Manning catalog. Today, I'll be demonstrating how to use Spring Cloud Function and Spring Cloud Stream to build event-driven applications and prepare them for also deploying on serverless platforms. So we'll also have a very quick look at Spring Native. Without further ado, let's get started. So this will be a very hands-on live coding session. So I'll go to my IDE now. If you have any questions at any time, just write in the chat and I'll try to answer. All the code that I'll be implementing today is on GitHub. So at the end of the session, I'm going to tweet the details to find the repository that you can also see here on screen. So the starting point, as always, with Spring is the Spring Initializer website. From here, I can start a new project. I'm going to use Java, Gradle, the latest production-ready Spring Boot version 2.4.5. I'm going to use Java 11. And as for dependencies, we have Spring Cloud Function, of course. I'm going to add also Lombok just to have some help reducing boilerplate code. I'm going to use Reactive Web. And later on, we'll see also how to integrate the application with Spring Cloud Stream. So I'm going to add that as well. Spring Cloud Stream provides integration with different message brokers. I'm going to use RabbitMQ today. So I'm going to add that as well. And at the end of this session, I'm going to demonstrate also using Spring Native. So I'm going to add that as well. So Spring Native is currently in an experimental phase. So we don't have the final 1.0.0 version ready for production, but still it already provides a lot of nice features that are perfect for our use case. So building applications using a functional paradigm and deploying applications to a serverless platform that can be Knative or maybe AWS Lambda, Azure Functions, and so on. So I'm going to add that as well. So this is it. I already have a project open in my IDE. I'm going to use IntelliJ. Here it is. So standard Spring Boot application. So there's nothing in it besides the files created during the initialization. If we have a look at the dependencies, we're gonna see one thing at a time. So I'm gonna start enabling only the dependencies that are required in order to work with functions. Basically, it's just the Spring Cloud Function Web dependency. Plus, I have Actuator and Webflux. We'll see in a moment why. But all you need to use Spring Cloud Function is actually the Cloud Function dependency. So what is Spring Cloud Function? It's a project that promotes using standard Java interfaces like function, consumer, and supplier to implement your business logic. So as a developer, you're gonna implement these functions using standard Java. And then the framework will provide a whole lot of extra functionality in order to integrate with different services and platforms. But the core part is implementing the business logic as function. So we're going to start with that. Plain Java, no Spring. Let's see how that works. I'm going to create a new class. I'll call it functions. Standard Java class. And here I can define our first function that accepts a string in input and provides a string in output. So let's keep it simple. So inside this function, I can do whatever I want. It doesn't really matter. What it matters is actually the signature. So like what is the input data and the output data. To keep the case simple, we can make this function a processor that converts to uppercase any input string. So this function interface is standard Java. It's been introduced in Java 8, so nothing Spring related. And here, so I'll get a message that is a string in input, and then in output, I can maybe log a message. So I'm going to use this annotation. This is Lombok, just to have a logger implemented. I want to say log info, just so we know that the function is executed, and say converting to uppercase. And that is the message. And then we return the string converted to uppercase. That's it. This is a plain Java function. So I can, for example, write a unit test for it. Let's do that. I'll create a functions test class. I'm going to use JUnit5, so we don't need the public modifier here. So we need an instance of the functions class. And then we can write a unit test. So test uppercase. What we do here is we have the input that is Spring Cloud, for example. Then the expected output, this is Spring Cloud, all uppercase. Then we can get the actual output from the function, uppercase input. So this is a function, so we need to call the apply method provided from the function interface. So apply input, and then we can assert that the actual output is equal to the expected output. Yes, let's run it. So the function interface that we can see here has a method apply. So to apply an input to the function, so it's the way we trigger the function, but we also have utilities to compose multiple functions. For example, we can say execute this function and then execute some other function. So using this and then modifier. And we can actually do that. So let's create, so the test is grid. Let's create a new function. Maybe in this one, we can reverse the string. So reversing the string in input, and then we can return a string builder message reverse to string. Yes, let's quickly add a test for that. Oh, in a second will be clear why I'm doing this. Reverse, so the input is Spring Cloud and the output, this is fun now. Let's see if I can spell it correctly. GNIRBS. And then we call reverse. Let's see if I spelled it correctly. So far we have two functions. They are very easy functions, but inside you can implement whatever business logic you need to. A nice part now is when we start composing these functions together. let's first see what happens in plain Java. We can have a new test method in order to demonstrate that. So we want to do uppercase, then reverse. So the input is this one, the output is the reverse string, but all uppercase, because first we do the uppercase and then we reverse. And we can do that easily with Java functions here. So we can do and then, not here. So we can have and then. So we have, oh no, so we want uppercase first, and then we have the and then apply functions reverse. We specify the input, so I'm saying uppercase and then reverse. Let's see if it runs correctly. I misspelled something. Spring, yeah, this is an R. So at this point, we standard Java is enough. We can define functions, so we can use functions to implement our business logic. It doesn't have to be just function. We can also use the consumer interface, which is like function, but accepts only something as input, because then consumes something, so there's no output. Or we can also use the supplier interface, which has no input, but it has an output. Things start to get interesting if we want to build a pipeline. So combining multiple functions together. So as long as we have functions using the same data type like this, then Java is enough, standard Java. But what if we use a different data type? For example, if we define a class message with only one field, content. Let's use some Lombok to generate getters and setters and constructors and all of that. Yes. So what if we have, instead of the reverse function, we have reverse with message. So instead of accepting a string, it accepts a message objects. So here we need to access the data from the content, and that's fair. But what if we want to combine it with uppercase? So here I cannot do reverse with message because the data types are different. So in Java, we need to use the same data type. And this is when I'd like to start using Spring Cloud Function. One of the features offered by Spring Cloud Function is a transparent type conversion. So you can combine different functions independently from the data type. And then the framework comes built in with several converters for you. So just like in web, you have different message converters. But you can also, of course, implement your custom converters. And that gets all transparent, like it's handled by the framework. So the code of your functions is not changed. So the only thing I need to do now in order to start using the features from Spring Cloud Function is annotating these functions as beans. And that's it. And in order to be considered, the class need to be a configuration class. That's it. The implementation is not touched. The function is still there. The unit tests are still green. So I can test the implementation of functions independently from the framework. But then when I add Spring Cloud Function, I get a lot of features. So we said the first one is transparent data conversion or type conversion. So let's see if we can actually make a pipeline where we use the uppercase function, which has a string as output, and reverse with message that takes a message object as input. So two different types. We can't do that with plain Java. To demonstrate that, I'm going to create a separate class here. Let's call it Cloud Functions Test. And here I can use this annotation in order to set up the Spring context. It's called functional Spring Boot test. Here it is. So in the unit test, I got the functions by instantiating the class. But right now, like it works for normal beans in Spring, I don't get them directly from the class, but I ask Spring to provide them to me. And I can do that in the test using an object called function catalog. So this is not something that you need to use in your implementation. It's just for testing the function. The function catalog is a Spring object where all the functions are stored, and you can use it to retrieve your functions plus all the enhancement that the framework provides for you. This is an auto while. Yes. So now I can, we don't need the public. Now I can do test uppercase, then reverse with message. And actually, I'll tell you more. I can even combine imperative and reactive objects. So it works if I have different data types like string and message, but I can also have a reverse reactive implementation, accepting a flux of string and returning a flux of string. So the input is a flux of string. So what I can do now is flux.map. And then in here, I can say message. And then this piece of code here. And let's remove all this extra stuff. We don't need that anymore. So this is a reverse function now. And I can combine it with uppercase. This is a test. Yes. So we have, once again, a string in the input, like Spring Cloud again. And then the expected output, I will copy that so I won't make mistakes. Yes. Here it is. Now, since I'm combining an imperative function with a reactive function, I need to use a reactive utility to do the test. I cannot use directly assert j after calling the method. So what I will do here is getting, first of all, from catalog, I want to get the function. So now here it's interesting. I need to specify the name of the function. Of course, I could specify uppercase like I do in Java. So I can call reverse or I can call uppercase, but I want a combination, the composition of the functions uppercase and reverse reactive. And I can do that using a special syntax in Spring Cloud function that is the pipe. So I can say uppercase pipe reverse reactive, and pay attention, no spaces should be between before and after the pipe's sign. And then we want to return an object of type function. So the catalog will look up these functions, uppercase and reverse reactive, and it will produce the combination of the two, or the composition. And the result is a function from flux of string, because when combining reactive with no reactive, the result is reactive, and returning a flux of string. So this is our function. Yes. So you can see here the types are different from the entry point of this composition, which is the uppercase function, where I have string and string. So all the type conversion is done by the framework automatically. So at the end, I can use the step verifier, which is a utility in Project Reactor. So if you are familiar with reactive applications in Spring, you can use this. So we create a stream starting from the function, and we say function apply, and we specify the data in input. Of course, now the input is a flux of string, so I need to say flux just input. And then I can say expect next. No. So expect next, yeah, it's a string. Let's see the specific syntax. Nice. I'll just cheat. Where is it? Yeah, it's not here. Oh, yeah, but so this is actually expect next. Yes, expect next equals expected output, and then we have verify complete. No. Okay, so there's something wrong. Oh yeah, we need something else here. Yeah, okay. Sorry about that. Let's go here. Yeah, it was easier. Expect next matches. Yeah. So output, this is a typo. Yes. So to sum up, I'm using the catalog to look up a function definition which is not directly mapped to any of the functions that I defined, but I can do a composition. And this could continue. So I could say uppercase, reverse reactive, and then maybe reverse again. So I can pipe all the functions that I want. And at the beginning, I can use a supplier. And at the end, I can use a consumer. So we have so far seen two types of two features of Spring Cloud Function. One is transparent type conversion. The other one is function composition. So this all happens behind the scenes. So the test is green. We don't explicitly call the catalog, but we instruct the framework to use the function that we define as a configuration here. So I have Spring Cloud function definition. Here it is. And using the same syntax, I can say uppercase pipe reverse reactive. So this is fine. So we get the features from Spring Cloud Function about this composition type conversion. We have more features actually, but how is this function triggered? And this is the very interesting part. So we can integrate this function now with several different services or platforms. So one of the easiest is using HTTP endpoints. So trigger the function through an HTTP endpoint that is generated automatically. In the class path, we have Spring Cloud Function Web, which contains Spring Cloud Function plus all the necessary utilities in order to work with a web application and Webflux. Actually, I don't need to do anything to make that work. Once I have my functions implemented using standard Java functions, consumers, and suppliers, I can provide a configuration here, and it works. So let's see, I'm gonna run the application now. So it started, it's running on port 8080. So now I can do a curl. Since I'm working with strings, I'm gonna specify as content type text plain, content type text plain on localhost 8080. Since we have only one function definition here, so it's a single definition, Spring Cloud Function will map automatically that function definition to the root endpoint. So I don't need to specify any endpoint here. The root is fine. And then I can pass a string, for example, my name. And in return, we get the string after being converted to uppercase and reversed. So I didn't have to do anything specific about that. And I can write tests for the web applications, of course, and I can build it and package it as a Docker container, for example, and I can run it on a platform like Knative directly, or I can use one of the Spring Cloud Function adapters in order to prepare this function to be deployed on AWS Lambda or Azure Functions or Google Cloud Platform. You can find all this information on the official documentation in Spring Cloud Function. Let's have a look at it together. So you can find both the guide about all the basic features of Spring Cloud Function, but also how it integrates with different other components. For example, for AWS, you can see that it's mainly about adding a new dependency to the application. And yes, it's shown here. So it's about adding a new dependency for AWS Lambda. For the other adapters, you need some extra code in order to instruct the cloud platform about how to integrate with the function. But still, just by having your implementation as functions using plain Java, when you add the framework Spring Cloud Function, then you get a lot of features out of the box. You don't need to worry about all the integration aspects or compatibilities. Of course, if you're going like the serverless way with where you want actually scale to zero, you also need very high performance and you need almost instant startup. So maybe packaging the application in the normal way, so on the JVM, might not be the most performant way, the most efficient way to do that. But Spring, with the Spring Native project, got you covered. So it's, as I said at the beginning, it's still experimental, but it supports, for example, this application using Spring Cloud Function. So all I have to do is uncommenting this plugin, the AOT plugin, and then I need to specify that when using the boot build image task, which is based on cloud native containers, to build automatically a Spring application as a container without providing a Docker file, I need to specify if I want a native image or not. So by default, this is disabled. So you get a standard Docker image based on the JVM. If you want a native one, then remember to set this flag to true. Now, compared to the normal way of building the application, building an application with Spring Native, or in general, native executables with GraalVM takes more time, takes several minutes, and it consumes a lot of resources. So I won't do this now, because with all the streaming, like my computer will not be happy about it. But I previously built a native executable that we can test together. And all I did to build it is running the Gradle task boot build image. The key part is this flag set to true. And of course, in your project, you need to have this plugin. If you set it up from Spring Initializer, you also get nice documentation if in your project that you just initialized, if there is any dependency that is not quite ready yet to be handled by Spring Native. So you can get that information. I repeat that it's experimental. So some projects are still not supported, but most of them, like Reactive Web, Spring Security, Spring Cloud Function, Spring Cloud Stream, are already supported. After building the image, I have one. Let's verify. So I think it's called web function. Let's see. Yes. So first I need to stop the application running on the JVM because I will use the same port. And then I can say dog run, the port 8080. Then the image is called web function. This is the tag. And that's it. Here it is. So right now, like considering my current resource usage on my computer, it's 0.165 seconds, but it's actually even faster than this on a standard environment. So it's really fast. If you're going serverless with Spring Cloud Function, then I recommend starting looking into the Spring Native project, even if right now it's in experimental, but very soon this year, the version 1 will be released. It's a really great project. Like with no effort, I can build a native executable. I really like it. They did a great job. If you need more information about Spring Native, you can check the documentation, of course. It's really detailed. So for example, the plugin that I showed earlier, the AOT plugin, it explains what it does. For some libraries that you might have in your project, maybe you need to provide some hints to the GraalVM compiler in order to produce the native executable. In that case, you can use native hints, and Spring Native provides very convenient annotations in order to provide that information to the compiler. Yes. So far, we looked into using the functional paradigm. So we implemented business logic. In theory, it was really simple stuff, but the point is that inside those functions, you can really have anything. It doesn't matter. What it matters is that at the end, from the framework point of view, you register the functions as being. That's the only thing in the code that is framework specific, because then everything else you can configure it from here, like I did. This is how you define a function composition, but you can also expose different functions. So if I say uppercase pipe reverse reactive, but if I want also to have access to the uppercase function, I can use the comma here. Let's run the application again. No, I need to disable this just to go faster. Yeah, it was just that actually, yes. So now we can use both functions, so uppercase, which maps one-to-one to my uppercase function, and the composition. Since I have more than one function, I need to specify what I want to call. So in here, I need to specify an endpoint, which is the same as the function definition name. So I can say slash uppercase, and then I get my name in uppercase. So this is it for the web part. We build functions. They are exposed through web endpoints. We can add some dependencies for the adapters to AWS, Azure, or Google Cloud Platform in order to make them ready to be deployed on those platforms. We can also just package the application as is using Spring Native and then deploy it to Knative and have all those features that we like of serverless platforms like scaling to 0. Another interesting application of these functions is triggering them through messages. So from an event broker. So really event-driven. We don't need to be concerned with this integration, so I will not touch anything in my code. So just like I enable the web endpoints just by defining the functions here and adding a dependency on the web project, I can do the same with Spring Cloud Stream and integration with an event broker like RabbitMQ. So what I can do is adding a dependency on Spring Cloud Stream binder Rabbit. So there are different binders depending on the broker you want to integrate with. On the documentation, you can find more information. So you have officially supported by Spring, you have RabbitMQ, Kafka Streams, but there are also other binders provided by the community and partners, so like Azure, Google, and Solace solutions, they are supported as well. In this case, I'm going to use Rabbit. So starting from the previous setup, just like functions declared as beans, I add this new dependency now. Second step, I'll start a RabbitMQ container. I'm using the default port 5672, and I have also this other port which is for administration. That's why I'm using the management version of RabbitMQ. And then once again, the functions are here. I'll keep the function definition. I need the definition also for a Spring Cloud Stream. And then I can start the application again and see what happens. So I haven't changed anything, not in the Java code, not even in the configuration. I just added a dependency on Spring Cloud Stream. So we're going to see more logs now because Spring will connect to RabbitMQ, and through auto configuration, set up everything we need in order to support triggering that. Let's see what is happening. So do we have a container running? Yes. We have Spring bound Rabbit. Let's try again. So there's not magic in this. Spring Cloud Stream is leveraging all the nice features from Spring integrations and the project called Spring AMQP, which is the one actually integrating with RabbitMQ. It's just that you don't need to be concerned with actually integrating your code with AMQP. everything is done by Spring Cloud Stream. So let's see what is happening. Rabbit health check failed. So there's something wrong with Rabbit. Oh, create a new connection. Yeah, so there was something going on with RabbitMQ. Okay, but let's see. I'll clean up the logs here. Let's see if it's actually working. We have defined uppercase pipe reverse reactive. So if now I send a message with a string, I would expect to see the result reversed. I'll use the reverse function here just because I think I have a log message in reverse, so we can see the result. Yes, perfect. And in the meantime, I'm gonna open up localhost 15672. This is the RabbitMQ administration. By default, if you don't specify any credentials, it's just guest. Here it is. Let's see if the application started. Yes. Okay, the first thing to notice is that by default, Spring Cloud Stream creates some exchanges and queues for us. The exchange has this naming here, uppercase reverse, which is the name of the function definition, then in or out, and then 0. Let me explain what that means. So it's a function definition dash in or out dash 0. So the function definition is what we defined in the application gravity file. If it's something with a pipe, we just remove the pipe and use the final result as a name here. In out is the input or output channel. So the input of the function definition and the output of the function definition. And then 0 for RabbitMQ will always be 0, but if you use Kafka, you have the possibility of relying on the partitioning functionality offered by Kafka. In that case, each partition would have a different index here, 0, 1, 2, 3. But for RabbitMQ, it will always be 0. This is a logical name. So this is how Spring Cloud Stream identifies the input and output channels in the application. And if you don't specify anything else, it will use them also as actual names for the exchanges here. And then it will create a queue for each consumer. We have only one consumer, which is the input of uppercase reverse here. And then there's a bunch of random strings. This is a temporary queue. Spring Cloud Stream will remove it when it's over. So clearly, this setup is really nice for demos, for trying it out, but it's not for production. But let's see if it works. So I'm accessing the exchange for the input channel. I can publish a message like Spring Cloud, message published. Let's see if it worked. And here it is, converting Spring Cloud. Let me zoom in. Converting Spring Cloud to uppercase and then reversing Spring Cloud. It worked. But again, like that naming is not really nice for a production scenario. We need something else. So I'll stop the application and we'll see how to address that aspect. So depending on your use case, these exchanges and queues are created either externally from some other through some other option, or if they don't exist already, Spring Cloud Stream will take care of it. But you're not constrained to the like using the standard naming. You can configure the bindings, and we can do that through the properties. We have the bindings here. Yes, we address the bindings using the logical name. In our case is uppercase reverse in 0. which is the input of this composition. And we can say that we can specify a name and we can specify a group. So if you remember, we had an auto-generated queue with some random strings. So instead of that random string, we want to use what is called a consumer group. A consumer group means that all the instances of the application in that group will read the message only once. So only one of those instances will read the message. And this is, of course, what you want if you, for example, have your application replicated and only one of them needs to get the message. So we can have the definition. We can call it maybe plain string. And then we have a group, which is usually for the group, I use the application name. Now it's just demo. So let's go with that. And then we have uppercase reverse out 0. In this case, I only specify the name, like processed string, because there's no consumer. So once I process the string, there's no consumer reading. So I don't need to specify a consumer group. All these properties, of course, you can find them documented on the Spring website, but you can also check the code for the binding properties here. So you can have a look here. So there are generic binding properties, but for RabbitMQ and for Kafka, of course, for all the specific binders, you can find extra properties. Rabbit binding properties. Let's see if I can find it. Yes. So with the Rabbit properties, you can specify things like, for example, if a queue needs to be transactional. So if you are saving a message in your queue as part of a transaction, which is usually the case if you're using something like the Saga pattern, where you save something in a database, and at the same time you also want to send an event about what just happened, then you need to make sure that these two operations either both succeed or both of them are rolled back. And RabbitMQ supports transactions, so you can find the transacted properties and set it from here. Yeah, another set of properties that is useful is about the DLQ, the dead letter queue. So you can specify the redelivery, you can specify really everything. You can just do it here from the application properties. So now, oh, this is wrong. This should be destination. So now we specified explicit names for the exchanges and the queues. Let's see what happens if I run it again. If you used Spring Cloud Stream before, maybe some older version, you might remember that back then you needed some extra annotation in your code. So you needed to specify annotations for the source, for the processor, the destination. But now your code is really framework free. It's just the beans and the configuration. And then I use Lombok, but really the function is just framework free. And this is convenient because not only you can use functions in your code, so in your project, but you can also import functions from other libraries, from jar files. And on the Spring Cloud Stream website, you can find already a library of different functions that might be useful if you build your own data pipeline. Let's have a look. Yes, so we have here the plain string exchange and the processed string exchange, their topic exchange, and the queue. Now we have plain string.demo. So this is not temporary. So this will survive the application restart because I've been explicit in what I wanted to use. So I can give it a try. one more time. And here it is, converting to uppercase and reversing. So about RabbitMQ, right now I'm relying on the auto configuration because I started the container using default values, but I can also customize that using the Rabbit properties here. Yes. So for example, if it's not localhost, I can specify some other host. I have the port, if it's not the standard one, and a few more properties like the connection timeout. Yeah. So already just by using Spring Cloud Function and Spring Cloud Stream, we have a lot of power in our hands. And as you noticed, it's almost transparent because after declaring functions as beans, it's only a matter of configuration and dependencies in here. And we can use both these projects, function and stream, as a basis to build our own data pipeline. The step further is to have a look at a project called Spring Data Flow, which is based exactly on this concept, where we have different common pieces of functionality of functions that we can use to build a pipeline, so a data flow. We can use our custom functions, but we can also use some from the library. And I want to show that on GitHub. You can find a few of them. So these are the samples. So it's a Spring Cloud Stream. Let's see, I need to find the name. But you can find information in the documentation. There's a link on Spring Cloud Data Flow. Of course, there are different implementations for the binders, but you can also implement your own. Again, you find all this information in the documentation. These are all the ones that are currently supported. And Spring Cloud, yes, it's actually here, Spring Cloud Stream. Yeah, this one, Spring Cloud Stream App Starters. So it's a different menu item here. So here you can find already some functions implemented. You can see all the available sources, processors, and sinks. So if you want to trigger our function definition, uppercase pipe reverse from a file, you don't have to specify like the logic of reading the file by yourself. You can use a file source from here. So there's really integration with different data stores, with different services, also Twitter. So it's really nice. And using Spring Cloud Dataflow, you also have a graphical user interface where you can combine all these pieces in a very intuitive way. And finally, remember Spring Native, which brings to the table really a lot of benefits when we talk about serverless and functions. This is it for today. I hope you enjoyed this session. If you have any question, feel free also to reach out to me on Twitter or LinkedIn. I have a book in progress, Cloud Native Spring in Action. And actually, I think maybe this week or next week, the chapter about event-driven applications will be published very soon. You can use this discount code, 40%, not just for my book, but for the whole mailing catalog. Having said that, I want to thank Manning, for hosting me today. I will publish the link to the code, to the source code, on Twitter and LinkedIn. So check that out also on my website, thomasvitale.com. And that's it. I wish you a great day and see you next time. Bye.